Question 9 of the DEB, it says, when thunderstorms occur, people often try to establish how far away they are from the lightning. One technique is called the flash to bang method, and it involves counting the number of seconds between the flash of lightning and the clap of thunder. Okay, and I'm sure you've all done that at some stage. But for part A, it wants you to write down a formula to estimate the distance in miles from where the lightning strikes. So for me to work it, it said that you count the seconds and then you divide by 5. So that's what we're doing. So the formula is equal to your time divided by 5. Okay, so that means distance is equal to time divided by 5. And you could have written distance instead of formula. Then it says use the formula to find out how far away does lightning strike is if there was a 20-second gap. So you would go 20 divided by 5 and you get 4. Okay, and that would be straightforward and easy. Okay, that's if you're using miles, and it says in Ireland we use a metric system. All right, so it said the speed of sound is approximately 340 meters per second, depending on temperature. So find the number of seconds that would pass between a flash of lightning and a clap of thunder if the lightning was 1 kilometer away. So 1 kilometer is 1,000 meters. So what I'm saying is 1,000 divided by 340 is equal to 2.9411, which is roughly 3 seconds. So it takes roughly 3 seconds for the noise to travel that far. Then it says, hence or otherwise, write down a formula to estimate the distance in kilometers from where the lightning strikes. So your distance in kilometers is equal to t divided by 3 if you're going with miles, right? Or your speed is equal to distance divided by time. We're going with this one. So speed is equal to distance divided by time. That will mean that distance is equal to speed multiplied by time. So distance in meters is equal to speed multiplied by time. Your speed was equal to 340 meters times your time. Right? So your distance in kilometers is equal to 340 over 1,000 multiplied by your t. Okay. Next part says, during a thunderstorm, 2 students standing at the same location counted 15 seconds between the flash of lightning and the clap of thunder. 1 student used the miles, 1 student used the kilometers. Estimate the distance from where the lightning struck using both methods. So for your mile calculation, you go 15 divided by 5 and you get 3 miles, and your kilometer, you go 15 divided by 3 and you get 5. Right? It says, given the conversion between miles and kilometers is 1 mile is 1.609344 kilometers, state whether the methods agree and explain your answer. So 1 mile is equal to 1.609344. So 3 miles would be equal to that distance times 3, which I am calculating as 4.828032. Okay, in terms of if they agree or not, you could argue and say that 4.8280 is not equal to 5.00. All right, they are 171 meters out. So you could argue that they didn't agree. Or you could say they do agree because the difference, your 171 meters, is very, very small. Okay, generally I'd say they agree. All right, part D, it says the speed of sound at a particular air temperature is given by a formula CT equals 331 plus 0.6 times T. And it wants you to calculate the speed of sound when the air temperature is 0. So you want to get C of 0. So C of 0 means instead of writing down your T, you're writing it down 0. So we're just getting 331 meters. Then it wants you to find the air temperature when the speed of sound is 340 meters per second. So 340 is equal to 331 plus your 0.6 times your T. Right? So when we tidy that up, you're getting 9 is equal to 0.6 T. So your T is equal to 9 divided by 0.6. So you get told basically it's at 15 degrees. Part 3, it asks you to write down a formula to estimate the distance from where the lightning strikes in terms of air temperature and the time gap between the flash of lightning and the clap of thunder. All right, so our speed of sound in air was equal to 331 plus 0.6 t. Our speed is equal to distance divided by time. So our distance is equal to speed divided by time, we said earlier. So our distance is equal to your speed times your time. So we're getting 331 plus 0.6 times your t. Okay. And then finally it says, hence or otherwise find out how far away the lightning strikes if the air temperature was 18 degrees and there was a 9-second gap. So your distance is equal to 331 plus your 0.6t times t. Okay, so you write 331 plus 0.6 times 18 times your t, which was your 9. So you're getting 3076.2, or 3.076 kilometers, or 3.1 kilometers. Okay, so that question was slightly tricky and slightly confusing, but if you just keep plodding along and write stuff down, it's better than leaving it blank. Okay?